Hey everyone, starting a new chapter here on a chapter 2. Today we have a big definition day. I know it's going to be a lot of writing, but I promise it'll be super useful. So right now, if you need to, just remember you can pause whenever, write down those definitions, whatever you need to do. Let's see if I can focus this a little better. It's a little better. All right. So today we are working on properties of numbers. So I have 4 major definitions for you today. I have my first 2 already up here on the sheet, so if you would like to start writing those, you're more than welcome to. The first one I want to talk about today is the commutative property of addition and multiplication. There should be a T right here. I don't know why. And commutative property of addition and multiplication. So this is actually 2 different properties, one for addition, one for multiplication. I know it sounds like a really big, scary name, but it's really not that difficult. The idea of this is changing the order of values when adding and multiplying does not change your answer. For example, if none of those words make sense to you so far, all I need you to do is look at these numbers right here with me. I've got 6 plus 4, and we all know that in our heads. We all know that's equal to 10. What about 4 plus 6? Oh, look at that. It's also equal to 10. That's an example of the commutative property right there. The idea that we can change the order. Changing the order when using adding and multiplying does not change our answer. 6 plus 4 equals 10. 4 plus 6 equals 10. 6, if this was 2 plus 2, or 2 plus 3 equals 5, 3 plus 2 equals 5. The order does not matter when we're adding and multiplying. Another example for multiplying. 9 times 5 is 45. 5 times 9 is 45. Right over here, I have a little algebraic formula version of it for you. If you want to see it like that, all it's saying is a number A plus a number B is equal to a number B plus number A, just what we showed over here. So that's the commutative property of addition, telling us that basically no matter what order we do it in, I'm just going to write any order works. So it's a cool way that we can rearrange some problems. We'll get some practice with that later. I'll explain it to you a little bit more. Basically, you need to know the commutative property of addition and multiplication means you can change around the order, does not change our answer. And that ties right in with our second one right here, which is the associative property of addition and multiplication. These are actually very similar. The associative property is talking about groupings. When we're talking about groupings, that's talking about parentheses, things like that. So if you look at our first example here, we have 2 plus 7 in parentheses plus 3 equals 12. So if we did that, we'd start with our parentheses. 2 plus 7 equals 9 plus 3 is 12. But also, if we have 2 plus 3, 7 plus 3 in parentheses, that also equals 12. Start with our parentheses. 7 plus 3 is 10 plus 2 equals 12. You can see the same thing with multiplication here. We have 9 times 2 is 18, times 10 is 180, or 2 times 10 is 20, 9 times 20 is 180. Any order, any groupings. Like I said, we'll get some more practice with this later. Here's once again, our little formula for that. Using our algebra, we got A, B, and C in there. A plus B plus C is going to be equal to A plus B plus C, no matter which grouping, and the same for multiplication. So here's a little practice of that right now. So if I'm going to show you right here, we have the same 3 numbers, but different groupings. But I'm going to show you it does not matter if we're adding or multiplying. That's important to remember. When adding or multiplying, we can do any order, any groupings. So I'm going to start with this right here. 7 plus 12 is 19. That leads to 19 plus 23. Some mental math there gets us to 42. We can do this too. 12 plus 23 would be 35. 7 plus 35, also 42. The groupings don't matter. Any groupings, any order. That's our commutative is about our order. Our associative is about our groupings. We can change those however we like. All right, so we have a little problem here. We have you spend $6 for dinner, $8 for a movie, and $4 for popcorn. What is your total? So we're going to try this a few different ways. We got 6 plus 8 plus 4. could also rearrange this using the commutative property, changing the order. I see that 6 plus 4, that's easy math. So 6 plus 4 plus 8, I know that's equal to 10, plus 8 equals $18. If we double check that, we have 6 plus 8 is 14, plus 4 is 18. Our order does not matter. We can change up the order to make it as easy for us as possible. All right. All right. Sorry about the interruption there. So we're looking at this again. We have two more rules down here that I'd like you to add. The first one is our additive identity. These are going to be things that you already know. Our additive identity, all it's saying is adding 0 to any number keeps the number the same. 12 plus 0 equals 12. I know you know that. 2 plus 0 equals 2. A plus 0 equals A. Our multiplicative identity, multiplying any number by 1 keeps the same number. 12 times 1 equals 12. 2 times 1 equals 2. Negative 5 times 1 equals negative 5. A times 1 equals A. So those are things that you need to know the names of. So I'll jot those down, pause right here if you need to, but not something that you need to really learn because it's something you already know. Awesome. So those are our properties. That's all of our formulas that we have for today. We're going to get some practice at it and move on from there. So I'm going to start pulling this up right here. We're going to do some name that property. So I'm thinking right now I know I've got the commutative property, that's about order. The associative property, that's about grouping. My additive identity means adding 0 to anything. Multiplicative identity is timesing 1 by anything. So our first one I'm looking at, I see 5 times 7 equals 7 times 5. They changed the order here. They flip-flopped these. When I'm thinking change of order, I know that's commutative. They changed that order. That's a commutative property, commutative of multiplication, I'll say. Because remember the commutative of addition and commutative of multiplication. Our next one, we have C times 1 equals C. That's our very last one we learned. Remember right here, we got multiplying 1 by any number. The product is the original number. C times 1, so we got our multiplicative identity. Three, 7 plus A equals A plus 7. What do I notice? They swap the order. When we're talking about order, that's our commutative again. This time, is it of multiplication or addition? Looking at it, we have addition, so we know it's commutative of addition. Good. Our next one, 5 times xy. Xy are in parentheses. Next one, we have 5x times y. 5x are in parentheses. They changed the groupings here. I see those groupings. I immediately know that's associative. And this one is multiplication because they're multiplying, not divide or not adding in here. Next one we're looking at. You've seen this before. They changed those groupings. Commutative. Commutative is, I think, one of the most useful properties that there is. And this is of addition. They're adding. Our last one, we got 8 plus 0 equals 8. That's our additive identity. Oops, I messed that up. There we go. All right, a couple more practice problems over here. We're going to get a chance to try some of these. I see 81 plus 6 plus 9. I look at this and I say, well, I know 81 plus 9. I know my 9s. 81 plus 9 would be 90. So I'm going to use the commutative right here and the associative, and I'm going to regroup and reorder. I'm going to go like this. Change that grouping right there. I see this. I know that's 90 plus 6 equals 96. I made that problem a little easier for me to do in my head. The next one, let's try to do the same thing. I see 19 plus negative 30 plus 21. I see these two numbers, and I'm like, oh, those will fit together to get really nicely. 19 plus 21, we can rewrite this. 19 plus 21 plus negative 30. Could even throw in some groupings there if I wanted to. I know that's 40 plus negative 30. I see that, and I know the answer is 10. I use that commutative, use some associative, use those rules to make those problems easier for you. Look at our next one here. School supplies cost $165, 85 cents, and 35 cents. What's the total? Well, I'm looking at these and I think the total, I'm trying to figure out what they are all added up. Now I noticed something. I noticed something right here. Those are going to pair together really well. So I'm going to go reorder this right here. I'm going to use my commutative law to reorder this. I see those. I know that equals to $2 plus 85 cents. That's easy mental math for me. 285. Use those laws to make these easier for you. Look at the next one. I see 4 times 9 times 5. I don't really know 4 times 9 off the top of my head, but I do know 4 times 5. So I'm going to reorder here. Reorder, regroup. I see that. I know that's 20. Oh, and I know 2 times 9 equals 18. Add that 0 on. That's 180. Make this stuff something that you can do. Make these problems easier for yourself. Right here, I see this. I know 3 times 4 is 12, but I don't know what 12 times 25 is, but I do know 25 times 4. I do know that one. So let's do that. Rearrange. We got 100. 25 times 4 is 100 times 3. Wow, that's a problem I can do right in my head. Reorder, regroup. All right, we got one more. This one's a long one. We got a lot to group here. 5 times 9 times 6 times negative 2 times negative 1. Well, right off the bat, I want to start with these two right here. I see negative 2 times negative 1. And so I'm looking at this. I'm thinking we can regroup, reorder here. I see these two. I like those. Negative 2 times negative 1. A negative times a negative. Always a positive. So I know that's going to be positive 2. Now I got 5 times 9 times 6 times 2. Let's see. What do I like here? I want to regroup this. I see some math problems I know. Let's do 5 times 6 times 9 times 2. Start with this. Get 30 there. Right here. I want to do these two as well. I might not have done this the easiest way, but it's the way I'm choosing. Now I'm down to 30 times 18. Just one problem I have to do in my head because I solved the rest. 0, 4, 0, 0, 3, 540. I don't know. Let me double check that one. I don't trust myself on that. Let's see here. 5 times 9 times 6 times negative 2 times negative 1. 540. There we go. All right, so that's a little bit of an example of different ways that you can use those laws. I know a little longer video today, but we got all those definitions done. Got some great practice problems in there. I hope this helped. Record, pause, stop wherever you need to get the rest of these notes down. Nice work.